In the name of Allah, the most merciful, the most gracious. Assalamu alaikum wa rahmatullahi wa barakatuh. For our math-241 project, we will be talking about using linear algebra in cryptography. Welcome to our presentation on the fascinating world of cryptography and its intricate connection with linear algebra. In our digitally driven lives, we rely on the internet for various tasks, from managing our social media accounts to accessing our bank information and handling sensitive company data. However, the convenience of the internet comes with a price. Some individuals exploit vulnerabilities to access this information for nefarious purposes, such as blackmail and impersonation. Today, we will delve into the core of our project, exploring cryptography and how it's intertwined with linear algebra. Cryptography is the shield that guards our digital communication and information. It is a method that involves the use of codes to ensure that the only intended recipients can decipher and process the data. Essentially, it is the art and science of securing information in a way that it remains confidential, authentic, and tamper-proof. As we move forward, we will explore the various techniques and principles that underpin this essential field. Now let's turn our attention to linear algebra, a crucial branch of mathematics. Linear algebra deals with linear equations and their representation in vector spaces using matrices. In simple terms, it is the study of linear functions and vectors. This field serves as the foundation for various mathematical and geometrical concepts. Our focus here is to understand how linear algebra contributes to the robustness of cryptographic systems, providing mathematical basis for the security we rely on in the digital age.
Okay, to start our process to encrypt words and phrases, we have to specialize a specific number to each letter in the alphabets. For example, we represent the letter A by number 1 and represent the letter B by number 2 until we reach the last letter, which is Z. It will be represented by number 26, and we use zeros to represent the spaces between the words. Okay, let's take example to clarify what we just said. We have this word which is mathematics. How can we convert it from letters to numbers? We will take each each letter in the word and convert it to its equivalent number. For example, M, it will be converted to its equivalent number, which is 13, and A, it will be converted to 1, and T, it will be converted to 20. Okay, and then we will take these numbers, okay, and we will put them in this matrix. Okay, how can we convert or encrypt a phrase? We will do the same thing, but we will put zeros to represent the spaces between the words. For example, the numbers from 12 to 18 represent the word linear, and the numbers from 1 to this one represents the word algebra, and we put 0 between them to represent this space, to tell the reader that there is a space between these words. Okay, now we will go to the next step to know how we can make a matrix. Okay, we can make a matrix, but before everything, we have to determine the number of rows and the number of columns. Okay, what does determine the number of the rows in this matrix? The number of rows is determined by the number of the word in the phrase. In this phrase, we have, as we can count, seven words: 1, 2, 3, 4, 5, 6, 7. Okay, then we have 7 words, then we will have 7 rows. Okay, what does determine the number of columns in this phrase? The thing that determines the number of columns is the word that has the highest number of letters. If we have a look at this phrase, we will find the word mathematic has the highest number of letters. It has around 11 letters. As we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, now how can we put the numbers that we found them in the previous slide in this matrix? We will put them in order. The numbers of the first row of the first word in the phrase will be in the first row, and the numbers of the second word will be in the second row until we reach the last word. Their numbers will be in the last row. Okay, for example, we have this word the word linear, it consists of 6 letters. We have 1, 2, 3, 4, 5, 6. What about the rest of the columns? We will put zeros. Why do we have to put zeros here? Because we have nothing. The word is complete. It consists of 6 letters. The rest of the column will be zeros. And here this word, it consists of 7 letters. As we can count 1, 2, 3, 4, 5, 6, 7. The rest of the columns are zeros because we have nothing to put them here. Okay, the word is complete. And this word consists of 2 letters, and we will have two columns with numbers, and the rest of the columns will be zeros until we reach to the last row, which represent the word mathematics, which is consist of 11 numbers. So all the 11 columns will be filled with numbers. For further encryption, we must transpose the previous matrix, and we will get this matrix, which will be more complicated and more encrypted. At the end, linear algebra has a lot of functions and has a lot of applications in our life. One of them is to send and store sensitive data, and we've shown you in this presentation one of the ways that you can use to store and save and send sensitive data. Thank you for listening. I hope you have enjoyed the presentation and you've benefited from it. Thank you again.